So far, we focused on writing functions that just display output. Such functions do not return any value. That is why they are called void functions, because they return nothing. On the other hand, we have value returning functions. These set of functions can do everything a void function can do, and in addition to it, return values which can be used in the parts of program that calls the function. Remember the random function you used in few tasks earlier? That is a value returning function. The most important part of a value returning function is the return statement. The return statement, which I'll demonstrate shortly, is pretty flexible. It allows you to return single value. It allows you to return multiple values. It can also let you evaluate a mathematical expression in it. Overall, the value returning functions and the return statement are pretty useful. Here is a function that returns the area of a circle when you send radius as input argument. The definition of this function can be simplified to this, where you can skip writing the line where you assign it to a variable. Instead, you can just write the expression in the return statement. The area is evaluated and returned back to where it was called. Here is a program where the function returns the surface area of a sphere as well as the volume of that sphere in a single shot. If you observe the function call closely, I have written these two variables here to catch the values returned, which are separated by a comma. So far, we have seen functions that return only numeric values. Here is a function that returns strings. When the function is called, it prompts the user to input first name and last name and returns both the strings. I'd like to spend some time on Boolean functions, which return either true or false. Boolean functions are very useful while writing compound Boolean expressions as conditional statements in decision structures or conditional loops. Now that we are discussing compound Boolean expressions again, I would like to highlight the concept of logical operators that act as short circuits in Python. To demonstrate that, I will use these two functions as my examples. At the first glance, both the functions seem to be equivalent. To check if the number x is divisible by y, you have to divide x by y and then find the remainder. If the remainder is 0, then you can say x is divisible by y. But when y is equal to 0, we run into trouble because we cannot divide a number by 0. So it is important that we have a Boolean expression y not equals to 0, which would be true when y is not 0, and it would be false when y is 0. Here is where it gets interesting. Remember, I mentioned Python interpreter evaluates the code from left to right. When a Boolean expression is false, which is followed by an AND operator, Python skips evaluating the code further, because if one of the expressions is false, the AND operator will result in false. Let me show you the truth table for AND operator again. There you go. Similarly, Python does short circuit evaluation for OR operator. If the first Boolean expression results in true, then the code after that is not evaluated. The result will be true.